Heyo, I'm just getting set up. I'll wait a few minutes to see if anybody rolls in. I'll give a little intro and then we'll start doing some tank stuff. Yeah, so sorry we didn't have a stream last week. Retrospector is asking how was DICE. People don't know, DICE is like one of several annual game industry conferences. This is the one that's more focused on the game business and less on game development. So it's a lot more like money people and marketing people. And we were there trying to pitch, trying to make connections. The biggest things that happen at DICE are its awards ceremony and its keynote speaker. Yes, hello. And those are thousands of dollars, so nobody really pays to do that. Everybody just kind of hangs out in the lobby of the casino where it takes place in Las Vegas. And just tries to have one-on-one meetings in bars and stuff. And so that's what we were doing. It was very busy. We met a whole bunch of folks. We had a bunch of good meetings of people who told us other people to talk to, and so we're just trying to follow up on all that stuff right now. But it's still the big question for us is will this project get funded? How much will it get funded? And that will kind of change how we proceed and if we have partners. Our goal is definitely to have enough funding that people don't have to work pro bono, or we're only limited to rich people who can go without a job for a while. We'd prefer to have enough money in the bank that we can pay people to support their families and have a sort of sustainable studio. So that's what we're trying to do, and the game here is the enticement to get people to partner with us. So the work continues every day. But in the meantime, excuse me. Right now our big goal is to improve some of our demos before GDC. GDC is another conference that's next month. We've already set up a bunch of meetings for that, and we would really prefer to kind of spruce up our demo before then, especially because we'll be in a few, hopefully, indie game showcases then. And so one of the things that we're looking at doing is replacing some of these N64 looking low poly meshes with kind of assets that are not final assets, but at least give people the right impression of what the visual direction of the game is, and don't leave people thinking that it's just all gonna be kind of PS1 type stuff. In that way, I sort of jumped on the internet. I was looking at different asset packs, and I found this one for whoa, look at this guy. Tanks that kind of look more like Metal Slug stuff. To be sure, this is not gonna like ship with our game and is not quite the style that we're looking for, but it's at least hitting the level of polish that we want to communicate. So I was gonna swap out our tanks with these for now, just to sort of like spruce up our pitch demo a bit. I've already, as you can see, gone in and started working on the mesh swapping. Before I go too far into this, I will do a shout out on the artist who created these assets. His name, if you look him up on Sketchfab, is Slava Juravlev from St. Petersburg. I found these just by like going through like the Epic Unreal Engine marketplace, because it had them already sort of like pre-imported and stuff. And so yeah, you know, definitely wouldn't like use these in a release, because probably other games use them and you never want to see the same assets in your game and somebody else's game. But it does make for a good pitch demo, and it makes for a good stream, because I was looking at them and like the first thing that I noticed, even though it has a nice little like idle engine rumble animation, like whoa, those tank treads aren't moving. So I thought it might be like an interesting like sort of hour of stream to look into like how do we make that tank treads move. We can see there's these like straightaways where it's pretty straightforward, but our tank also pivots, right here, and that'll be a little interesting because when a tank pivots, right, like one tread is going to go one way and the other tread is going to go another way. And so like in those cases, we're actually going to want to have independent control for the left tread and the right tread. So yeah, let's just kind of like go into like looking at all that stuff. And if we still have some time after that, I was thinking we can start looking at how to actually aim the turret. Oh, I should here, I'll post the link to that artist portfolio in the Slack just in case you couldn't see it in the address bar when I was showing it off. Yeah, we can also, like, once we get sort of those treads going, I think like maybe the next thing would be to handle like controlling the yaw on this part. Maybe having, looks like we can do about 10 or 15 degrees pitch on the shoulder part, and then the gun itself can probably do another 30 or 45 degrees of aiming. So we can translate the actual, like, you know, when these enemies are aggro, they have a target position, and we want to come up with a firing solution, like a combination of rotations that sort of like point in the direction of that target. You know, tank stuff. So yeah, I'm gonna get started on that. I'll like talk through it as I'm doing it, because I'm trying to make these streams more educational. But also, like, if you have any questions about the project itself, I can always go on like tangents or digressions to show some other things. And yeah, if you just have like general questions about like how game development works as well, like I'm always like game to just like answer any questions. So hopefully this one's like simple enough that like it'll be pretty easy to follow along. There'll be like a little bit of code later, but I'll try not to just like go radio silent while I'm typing tons of code. Like I'll try and talk through it as I'm doing it. So yeah, I'm gonna silence the mic now. Looks like the boy is settled down for a nap, but he'll stay with us today. Yes, sir. And yeah. Oh wait, let's find him better. Cam. Okay. So yeah, great. Just hit me up in the chat if you want to ask anything. Otherwise, let's start looking at these tank treads. So the tank tread material is here. It's called, this asset pack is actually for spider tanks, so all the assets have like spiders in their names. which there's this old joke that's like, they say you eat a dozen spiders on average every year while you're sleeping, but that's actually a statistical anomaly because you have to discount Spiders Georg, who eats 1 million spiders a day. But every time I see spiders in the file names, I think like, oh, this is Spiders Georg's asset. Wow, that was a weird tangent, Max. Thanks. Cool. So the treads, it looks like they're just aligned to the, like, in texture space, instead of saying like X and Y, like on a graph, like in algebra class, you say U and V, or V is the vertical direction. That's why it says here, it says UVs. That's like an input. But it looks like the tank treads are just along the V direction. So I wonder if we just take the texture point, and then we just add, make float 2, and then in the vertical component here, we just add like time. I think that this will just like make it, this should just go, right? So we'll plug that into the color, we'll plug that into the normal map. And then this is kind of weird because it's projected on a sphere, but if, yeah, we look at it like on just a flat plane, it's pretty dark, so maybe it's hard to see, but it looks like it's scrolling nicely. So yeah, there we go. That's the beginning. That actually looks pretty good. Okay. Well, we're making progress much faster than I thought. So now, if we look at it in the scene, they're kind of always going forward. It looks pretty good when he's on the straightaway. I'll have to like adjust the speed to make sure it actually matches the time on the ground. But then when he's turning, obviously it's a problem because one needs to reverse. So I think in this, yeah, it just has a single material for both tire treads. So we're gonna have to basically have a different scrolling speed depending if you're on the left or the right side. And if we look at this, yeah, so I noticed this earlier. These meshes are actually not authored the normal Unreal way. They're actually sideways. They're pointing down the y-axis rather than down the x-axis. I think that might be because maybe these assets were made in Blender, and that's like the Blender standard. But since I don't have the original FBXs to re-import these, I think I'll just like stick with this and say like, okay, this tire is the one that's in the direction of the positive x-axis, and this one's the negative x-axis. So let's say like we can get your vertex like local position. Yeah, local position, and we'll do excluding offsets, which I think gets us like without any of the skeletal animations. We're going to plug this into what Unreal calls an if node. If is basically, this is like what in shaders, I don't know why Unreal calls it if. It's such a weird name. This is what every other shader language calls step, right? Where you have like a value A, and then you have a threshold B, which we set to 0, and then you can pick like, here's the output when A is greater than B, and here's the output when A is less than B. So we're going to say when A is greater than B, it's going to be time. When A is less than B, we're going to say like negative time. And hopefully what this means is that one tire tread is going, oh, it didn't like that. Why didn't it like that? Oh, it's because I fed the whole position and I only need the x-axis. So you can isolate that, the x-axis by saying component mask. They sort of freely, in their materials, like vectors are never like x, y, z, omega. They're always RGBA, so like x would be r. So all we're saying here is this position, the x has been R and X are just the same. Let's say it's weird. Shader people are not very consistent about this. Sometimes they say XYZW, sometimes they say RGBA. It's just different labels for the same thing. We want the first component, the X component, from the position. We plug that into the if node here. And now you can sort of see it on my preview here, hopefully. Everything on one side is going in one direction, and everything on the other side is going in the other direction. So now if we look back at our tank, yeah, cool. So now we can independently control the treads on the left and right side. So now we can see, what was it? If this value is positive, let's just plug the positive value back in. If this value is positive, it's going forward. Chug, 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 chug. If this value is negative, it's going backwards. Chug, 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 chug. So then in this if branch, the ones that are greater is going to be the one that's going forward. So that's this one. So the greater than direction, yeah, is the left tread, and the less than direction is the right tread, right? So the left tread is currently going forward, and the right tread is currently going backwards. Cool. So now we don't just want it to be fed by time, we actually want to control it. We want to write some code to say, I want the tread to be in this tread to be in this position, and this tread to be in this position. And then in our gameplay code, which I can swap over to real quick for the tanks, you can see it has this patrol state that it's in when it's not aggro, and it has is pivoting when it's like turning in place, and then it has this else branch here when it's just following its spline, like this this path down here. You can see the spawner has a path. We can like warp it, and this path like determines at runtime like where it goes. Boop, 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 boop. So like what we're really going to want to do is basically just get like the velocity at the left tread position and the velocity at the right tread position. And then we're going to want to advance those tread positions based on the speed, based on whether it's going forwards or backwards. Yeah, this all makes sense. So that we'll get to that shortly enough, but we, instead of using time, basically we want to have an input parameter. So single inputs in materials are called scalars. So we'll say we want a scalar parameter, and we said when it's greater, that's the left. So we're going to call this left tread phase. And then when it's less, that's the right side. So we're going to have another scalar parameter. I'm going to call this right tread phase. We save it and apply it. Now you see these are like nothing's happening. They're just stopped in place. That's because nothing's actually driving these parameters. But and once again, I don't know how hard this is to see because it's so dark. But if I was to like adjust the left tread phase here, right? 0.1, 0.2, 0.3, right? You can see it's like just it's like we've created an input that we can drag. Cool. So now we know that tread is material number 1 on the legs component. So let's go back to the code. We're going to convert this material into one that we can drive, and then we're going to begin driving those properties. So I need to shut down the engine because we're going to start editing code, and let's do that now. So we'll create a new U property, transient U material instance dynamic. We'll call this the tread mid. So material instances are like an actual, like, you may have like a bunch of things with the same material, and then each instance of it has its own material instance. And then dynamic means we can actually change the parameters at runtime. And then I'm making this an actual U property of the class, because this is like a thing that tripped me up on earlier projects. Once you create this, it will live until it gets like garbage collected, which is this thing, which is like if nobody's referencing something, then Unreal just releases it. And Unreal's garbage collector can only track pointers if they've been marked up as a U property. So if like we didn't like call this a U property, then like we'd save a pointer to it, but the garbage collector would free it at some point, and then we'd be left with a stale pointer, and then our game would crash. So. Now let's go into begin play, way down here. For our, I can just show you how my code is set up right now. All the game logic for the tank is in this tank class, which specializes the enemy unit class. The class is just like a type of object like a type of game object. And then for my old like N64 looking tank, I specialize it and call that the posable mesh. And then I have just a simple posable mesh component. This is like an Unreal component for like meshes with bones, and you just want to adjust the bones manually rather than have an animation drive them. And then I also have this one, which is Enemy Tank Mesh Construction Kit. And like Mesh Construction Kit was just the name of the asset bundle that Slava made. And so I'm naming my like specialization that uses those kinds of assets after that, right? And you can see this one has several meshes because the asset kit was actually modular. So it has a bunch of different pieces that you can Lego together. And so you see there was like a legs, shoulders, cockpit, gun, backpack, and antenna meshes, rather than it all being like one mesh. So now, to initialize this tread mid in the begin play, let's say tread mid equals was the legs component, create dynamic material instance, and that was index 1. Was the name. So then we're going to ensure that like tread mid is not null. We're also going to do like a quick ensure. Yeah, we're going to say like if legs, whatever. Yeah, actually let's do that. Let's say if legs component get num materials is less than 2. Like check that like these legs have 2 materials before we try and like convert material 1 into it. This is another like annoying programmer thing. Programmers start counting at 0. So the first material is material 0 and the second material is material 1. Otherwise, you know, we're gonna say I don't think that this is going to have less than 2 materials. All this ensure does, Retrospector is saying, you're telling me normal people don't start at 0? I mean, math people don't. I got a math degree. We always started counting at 1. It was like broke my brain to start counting at 0. But yeah, all this ensure statement is kind of like a lot of times you have statements in program called assert, in which you're like, something needs to be true or my program is broken. And if it's not true, then your program like shuts down and it gives you an unhelpful message like catastrophic failure or like something went wrong, sorry, teehee. This is a kind of weaker one. This is like, we're pretty sure this is going to be true. We can recover if it's not true, but we don't like it. And if we ever hit this, then like, and we're running in a debugger, then the debugger is going to like automatically insert a breakpoint. And we're going to be able to go in and say like, oh, something that I wasn't expecting to happen happened, and I can like actually investigate that. But when other people are running it and they don't have the code, they're just like double clicking the exe or whatever, it just passes through this, right? So now we just need to make sure to like not touch tread mid, except like whatchamacallit, if it's non-null, right? So that's the first thing. And then I think the next thing is we're gonna wanna, I think, do enemies do a normal tick or do they have a special enemy tick? I think I gave them a special enemy tick. Yeah, tick, enemy units, which just calls handle event. Yeah, so I just need to override handle event. This is just sort of like how I set up my my game code to be a little more sort of forgiving. Instead of having like a million, so like virtual functions, introducing so many things. Virtual functions are this thing in C++, which are kind of like event handlers. Like something happens and you want to respond to it. And like enemies and like other things have like lots of stuff that can happen to them. And if you created a different, like the normal way is to create a virtual function for every event, but then you end up having a million of them, and they're like, it really spaghettifies your code. I kind of take this strategy of having like a single like handle event function, which just receives the event as data. And then you like have a lot more flexibility in how you handle it, but also like all your objects don't have a million functions. They just have this one function. So we're gonna come in here, gonna do the ceremony, make sure this is right. So what we're gonna say is first, run all the gameplay logic for the tank. And then, if event, whoa, what is that? Sorry, Ryder is gets a little eager in, like suggesting stuff sometimes. But, yeah, if event dot ID is, what's this type? Is enemy event update. Yeah, so here's like our little branch here for when we handle just a general enemy update. And what we're going to do is we're going to update the tread. Oh, if we have a tread mid, and the event is update, then we're gonna like update the tread, right? Unfortunately, I got the names of those parameters that I just created, right? Like, was it left tread phase, I think? These aren't the exact strings I typed before. I'll just copy paste these in there. But what I'm doing here is I'm declaring some F names. F is the weird Unreal convention of putting the letter F in front of like every single struct. I think it's because they used to want to differentiate between when things are floats or single precision and when things are doubles or double precision. So you'd have like F vector and D vector. But then they just put F in front of everything, and even in Unreal 5 where they changed most things to double precision, they still have the letter F. So F is just kind of like a vestigial like thing. I always read it as like FN, like as an FN name. But F names are specifically, it takes this string and it converts it into an integer, just like a serial number, and those numbers are guaranteed to be different for different strings, but the same for the same string. So most of the time, instead of passing strings around, you're just passing these like serial numbers or hashes around. And we make it static basically to say like, oh, just compute that hash once when we start up the process, and then like for the rest of the time we're just going to be passing integers around. And this is because like integers are way cheaper than like strings for just doing like quick little like internal identifiers. So Here you can see tread mid has a function set. We called those scalars in the material. So scalar parameter value, name, left, tread, phase. So here I can do kind of what I was doing before. Actually, let's make some properties. And then let's just say left tread phase plus equals dt, right tread phase plus equals dt. So this is kind of what was happening when we just used time directly in the material, only now I'm accumulating that time in code and then sending it in. So just to make sure that this is different, let's say that this is like 2 times, we'll say that this is -1 times. So one should be going, the left tread should be going forward twice as fast as it was before, and the right tread should be going backwards. And this will only happen when the game is actually running. We won't see it in the like preview window. But let's go in and wait. Almost had a typo. Let's make sure we didn't write any bugs. I briefly stopped paying attention to you, little prince. Okay. That all ran, so let's start up the engine. Up it up it up. Cool, so now when I whack play, we should be seeing, yeah, the right tread is going forward. Wait, the left tread is going forward really fast, and the right tread is going backwards. So now, yeah, we have this like control. So I think what we want to do next is we're going to actually like have some probe locations, like on the left side and the right side. Where'd it go? Oh, it opened on my other screen. So yeah, now what we're going to want to do is have like a probe right here on the left side, and then a probe over here on the right side. And we're basically gonna, I'm just gonna like compute their velocity. We're not even gonna think about, yeah, so we're just gonna like, so we're gonna have like a probe over here and a probe over here. We're gonna see the speed of those probes, and then the speed of those probes are gonna control how fast we go, control this left and right phase. So let's say this is going to be a new property, edit anywhere, blueprint, rewrite, and we want it, it's going to be a position. Local tread probe position. But like we want to actually see a little point in the editor that we can drag around, and you can do that with this meta tag. So you say meta make edit widget equals true. come in here. Let's create some new properties. Let's actually make a struct. No. Yeah. Let's make a struct for each tread, right? Let's say tread state. Rider, stop that. Every time Rider recommends things. Okay. Sometimes it adds headers. It's starting to annoy me. There's probably a way to turn that off. But so we want phase. Previous position, previous time. So we're going to say this was our last probe position, this was the last time we probed, and this is our current phase. So then we're going to have two of these, tread state, left tread, tread state, right tread. And then in begin play, actually, the previous time, we'll sample them both at the same time, so we only need one, right? Last tread time. Last tread time is... And actually, we can express that as so last tread time dot set now. Left tread, then we can say left tread's position is, we're going to take the actor transform, I'm going to say transform position, and this is the local tread probe position, and then right tread dot previous position, and then the other position, basically it's y is the side to side axis, so it's like 1, -1, 1 times local tread probe position. Then when we're updating, we can say now, we could say tread time elapsed is our current time minus our last tread time now. We can get our new positions. Now we can compute the speed, right? So const float left speed is the distance from left tread's previous position to the new left position divided by tread time elapsed. Let's actually make sure that some time has elapsed and we're not paused. If we're paused, the treads don't need to update at all. Float right speed is the distance from right tread previous position to right position. And then down here we can say left tread So this gets us the absolute speed that those positions are changing, but we actually want assigned speed. We want to know if you're going forwards or backwards. So we also want to get actor forward. And then we can say left sign. Here, let's just say like left offset is left position minus left tread dot previous position. Right offset is right position minus right tread dot previous position. So now the speed is just left offset dot size. This speed is right offset dot size. Actually, let's just say like it's left off dot actor forward. So this bar Unreal over this is operator overloading. This takes this to mean dot product. So the left offset dotted with a unit vector will give us the length of it along this vector, and it'll be signed. If it's like going in the same direction of the actor, it will be positive. If it's going the opposite direction of the actor, then it will be negative. So like if it's reversing, we're going to go back the other way. And now we're just going to say left tread phase plus equals left speed times dt. Not name, just the parameter. Now, one very crucial thing, the units of this phase, is like, I don't know, it's however many treads were in that material, right? So that was like, of the little sub-treads, I think it was like 5 or 6 of them, but the speed here is in units of centimeters. I think those treads are like kind of bigger than a centimeter, so we need like a multiplier, like a unit conversion. This is centimeter to tread material multi. And I think we like have maybe like let's just say I think it's a meter per. Let's actually just make that a parameter. So cool. So just to clarify what we did, we're like probing, we're like testing the, oh, whoops, I forgot to save the actor transform here. So we're going to have probes on the left and the right, and if a non-trivial amount of time has passed since the last time we checked that probe, then we're going to compute the new probe positions. We're going to see how far they're offset from their previous position. We're also going to project that along the forward axis so that we're only measuring forward-backward offsets. And then we're adding that that offset like into the phase. And I'm trying to think about it here. Actually, I don't think I need to do this time stuff. Like, I think the offset in the position can just be directly matched to the offset in the tread. So let's get rid of DT here. And then let's just convert it directly from how much that probe has moved, right? So if you move twice as far, the treads will cycle twice as much. Cool. So this all looks good. Let's fire up the engine again. Or am I already running? No, I'm not. It's building. So now this might be kind of hard to see, but let's go in here. Oh, of course, I need to actually move that probe. Why does this thing keep opening in a tiny window off screen? So we had that local tread probe position. I don't actually see it here. Why can't I see it? Normally, wait, am I only able to see this if I drag an instance into the scene? Does it only, oh yeah, that's annoying. It only, okay, so like here's that local tread position that I was talking about, but for whatever reason, it only renders in the level editor, not the preview editor. So I'm gonna need to adjust this here. And then here, copy, and then paste it. Local tread probe position. Look at these guys go. They're going way too fast, right? What's happening there? Maybe that multiplier needs to be like way smaller. They are still going crazy fast. But it's actually pretty good. Wait, I think I just really underestimated how small this number needs to be. But okay, now it's going way too slow. So let's multiply it by 5. Is that a good one? You know what I'm gonna do to make this easier to see? I'm gonna like make some like glowing lines on the tread. Just so it's like trying to look at this like dark material is making me crazy. So let's go in here and let's just say like component mask. Actually, what if I just plug this into emissive? Does that make it brighter for now? Just for seeing? Yeah, that's looking pretty good, actually. Let's, I can just like slow this whole scene down. We'll come in here, begin play. Set the time dilation to 0.1 seconds. So now we should be in slow motion. And we can see, ooh, those are going way too fast. Look how crazy fast those are going. That seems hella wrong, right? So let's take that multiplier down. Just making sure there isn't like a bug in my code here, right? Position, offset, left tread is left position, right tread is right position. Dot with forward, dot with forward. Oh, I don't need this time elapsed. Oh, that's why that number was so small. There was just a typo. Okay, we can make that number bigger now. So 0.01 was, right, like it'll go through one phase of the tread every 1 meter. Okay, that time is like way too slow. Let's speed it up a little bit here, folks. Let's go at half speed. So 0.5. Zip, 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 zip. Seeming okay. And then it rotates around. I think when it's rotating around, like, I think that projection, let's do like, rather than just getting the distance along this axis, let's get the sine distance along that axis. But still get the like full distance that the thing traveled. So gets here. Still don't love this. It's like it's not moving fast enough when it's turning, right? And it seems to be going backwards sometimes too, right? Am I crazy? Yeah, those are like going the wrong ass way. I'm making myself crazy looking at this. Let's slow it down a little bit. Let's go to quarter speed. So when they're on this straightaway, it's like mostly looking okay. But then when it's turning, what if we take that local position and we just like double it? Just like exaggerate the effect of turning. They're 100% going the wrong way. It's making me crazy. Why are they going the wrong way? Have I got them mapped backwards? What if I negate this? It doesn't make sense that I would, but let's see. Then it turns around. Well, Well, now it's looking right? Or is it backwards still? No, that's right. Okay, I'm like a crazy person. I guess the left one would be on the negative side. I just had it pointed the wrong way. Okay, this is super cool. So it slows down here, and then they're going in opposite directions while it's turning. Doesn't appear to be a lot of sliding on the ground. I mean, I can't imagine that the number I picked out of my hat perfectly matches, because it's like dependent on a lot of things. But this is like basically seems like it's working. Let's watch it a little longer. Let's take this down. And actually, let me yes, right now that local tread position is like it's probing right here. What if we probed closer to the front of the wheel? I think that'll give us like a little more accurate result. We'll just keep it on the outside there. And then we'll just say apply instance changes to the blueprint. So this, when it's turning around, this should make like the forward turning wheel a little more accurate. Okay, let's take the speed back up to full speed. Get rid of the time dilation here. And just see. This is looking so good, dog. Oh man, I'm so excited. Are you excited, little man? Like to be disturbed in his nap. Too bad. This is when you're most cute. I'm so proud of this. Okay. Cool. So yeah, we're at about the halfway mark. That was actually faster than I thought. I was wondering if that was actually going to take us... Andy says we have the Foley as well. Yeah, that's like an old animation thing. Like when you're learning animation, they kind of... One of the things you learn is to like... communicate timing with just like onomatopoeias. Like it should be like zhuopat or like zhuopat, right? Like that's just like an easy way to talk about like easing and timing and stuff like that. But so like I can't help myself like making sounds for stuff when it's moving around. But cool. So now the next thing we need to do, if I go back to the original tank, this is where stuff's going to get a little annoying and messy, but bear with me. In the original tank, so this dingus has like aggro, so like if I play in my... What the heck? Did I say jet instead of tank? I did. I spawned the wrong type of enemy. I spawned a jet. Here we go. I'll spawn a tank. So these have aggro, right? So they turn, and then they start shooting at you. There's a bunch of stuff about the way I did this when I was doing things quick and dirty I don't like. One is that it doesn't shoot directly in the direction of the barrel because it's actually trying to be a bit smarter about it. The other thing is it like simplified things where like if the character didn't actually rotate to face you, but instead I just had like an animation bone that was like turning its whole body. It seemed really clever at the time. I was really proud of myself for writing less code, but it's actually really annoying and bad. So subsequently, if I go to my new tank, which doesn't have any of those bones or anything, we're going to have like an annoying situation where you see it's like not rotating and it's like muzzle's not set up correctly. So we need to get the aggro state on this working. Also, its material doesn't have any of our like damage effects when we shoot. So actually, let's start with those damage effects. I can show you how like damage effects work in our game. So we are going to want to go to the main material here, which is Spider's main. You can see I took their original implementation and just had like a texture sample for the normal and the color. What I've done is I've added some of its color into the emissive channel to flatten the lighting a little bit. I've also added a Fresnel. Fresnel is this like rim lighting that you see. That helps it pop against the background a little bit. And I also made it totally rough, which is basically just to kill the specularity for now, because we are going for more of like an illustrated look and not like a physically based rendering look. But yeah, the way that, but like we use like colors to do damage, right? So when you're damaged, it flashes black and then white in like really quick succession. That's like an old like Metal Slug trick for making things extra flashy. And I wrapped all that up in a material function that I call damage flash. So you can see here's an amount that we want to add into the emissive colors. We're going to add that. So we add that to our emissive color and plug that into the emissive. And then we're also, mod is how much we want to multiply like our base color. So here we're going to multiply our base color channel by this. And now it should do the damage flash. Although I think this material, it's only driving the main material, like it has multiple meshes. I think it's only the legs are gonna flash. Yeah. So the first thing we need is for the whole body to flash. So let's. Oh, and also the tracks are going to need that as well. So let's go into the tracks here. We're going to multiply our color, texture by the damage mod. And then we're going to add the damage emissive into the emissive channel as before. Look how messy these noodles get almost immediately. I hate it. But so all the other tank parts though, I think they use this same Spider's main, right? Spider's main, Spider's main, Spider's main, Spider's main, Spider's main. Everybody else just has one material and it's Spider's main. So what we're going to do in our init function here is so here we're just going to say initialize tread phase, and then over here we're going to say create dynamic material for legs and assign dynamic main material for legs and assign to other meshes. And let's actually we're gonna add some properties, so we need to shut down You'll notice sometimes I shut down the engine when I recompile code, and sometimes I can just do it on the fly. You can only do it on the fly if you're just changing instructions in a function, but once you start changing properties, like adding stuff to a declaration, that's when you need to like shut down Unreal, recompile, and open it back up again. Because these changes change the layout of memory, and Unreal's code patcher can relay out code, but it can't relay out like memory. So. Boop, 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 boop. Yes, so what I was going to do was I was going to make another property for the material. We'll call this main mid. And we're going to say main mid equals legs component, create material instance 1. And then all the other meshes here, so shoulder, cockpit, gun, backpack, antenna, they're all going to use that same, they're all going to use the same material instance. Yeah, and like mid, by the way, here, this just means material instance dynamic. So we're going to say set material. Oh, actually, we want material 0 is the main one. So set material to main mid. So now let's compile and fire this up. And now everything except for that tread should flash. Yeah, there we go. Cool. So now we want to get that tread to flash as well, and all of that handling is being done in my my base type for enemy units. So let's go to the enemy unit base type. This has try damage flash. And so this one just has main material index. Yeah, so this one just does flashing on a single material. So I think instead what we want to do is say main material index and then main material count. Say for int it equals 0. So that's the main material count. So now we can do a sequence of materials and not just a single material. This doesn't cover all cases, but it covers all the cases we have so far. I try not to like over-engineer stuff. I try and like just solve the problems I have. So now we can go to tank 2. And it says like main material. Yeah, so main material index is 0, and then the count is 2. So now it should touch both the body and the tread. Yeah. And actually, if I look back at the old tank just had a single bounding box for everything. That seems wrong, right? Like we should have several bounding boxes. So let's just make this bounding box only cover the treads. Zoop. Zoop, zoop. And then, let's see, I'm going to duplicate that. And we'll put the duplicate under the shoulders. I'm going to give you a little scale. Now let's have a second box stuff up here. I'm gonna turn off real time because it's kind of hard to edit boxes while they're animating. Yeah, I could just probably eventually I'll just do the collision settings on these. Well, I wonder, can I just do collision settings on the individual pieces instead of... I'll just do boxes for now. Let's not make it overcomplicated. I can always fix this later. This isn't like a real asset. This is just like a temp thing. It doesn't matter if it's like super great. It just has to be good enough. So there's over the wheels, there's over there. And then... yeah, let's actually make this like a skosh smaller. Maybe like back it up just a little bit. There we go. And then, do we care? Yeah, let's do a box for the weapon as well, or for the barrels of the gun. Yeah, so these are the hit boxes that you can actually shoot, by the way. And then the antenna is just agreeable. We'll leave it alone. There we go. So the next thing is to make sure that it actually shoots out of its barrel. So let's look at this gun. Does it have sockets? Oop, I want to look at the mesh, not the material. So what type of bones are we looking at here? There's barrel end, barrel end, barrel 2, barrel 2. This is very weird. This is very... What is going on with this rig? I guess it's only designed to do this. And then these are just like... yeah, so... probably because he was doing a bunch of different variations of the gun, he just put the same rig on all of them. That way it could like share the same animations, even if like the bones don't like perfectly line up. Anyway, I want to have muzzles that are like really, like I want them to be tight on the end. I also want the rotation to be correct, right? Like red is the forward arrow in Unreal. Oops, it's pointing the wrong way. They've got like up forward. That can't be right. So what we want to do is create some sockets. This will be like muzzle A. We're gonna rotate it so it's pointing forward, rotate it so it's pointing up, and then like offset it so it's like inside. We're gonna move it inside there a little bit because like usually the bullets like travel a little bit. Andy says if we rotated 90 degrees it would make the cartoon awooga eyes. So there's the first muzzle. When it fires bullets, they'll be pointed forward and their up will be up. Let's make a second socket. We'll call this muzzle B. So the same thing we did before. Should be pointed forward. Should be pointed up. And then get it right inside there. Let's look at this like from the let's line this right up in the middle there. We'll just line this up right with, there's like a little tube inside of there. It's good enough. now in the code, what do we call that? Muzzle A and muzzle B. I added a virtual function just because like the muzzle is located relative to assets, and the assets are different for different types of tanks. So I just like abstracted this out to a little function called calc muzzle location. Bones, kind of like other things, they're just F names in the code. So we have muzzle A, by the way, this static like specifier that I'm using here, I also used it up here. It doesn't matter if you put it before or after the const, but it's probably better to put it first. This static means that this is actually a global variable. It's not like a local variable in this function, but because you've declared it inside the function, it's not visible outside of this function. So that's pretty useful. It also has this thing in C++ where the constructor is deferred until the first time that this is called. It's not really a big deal for like hashing strings like this. It does make a big deal if you're like using function local global variables to represent like singletons and things, because then you can control the order that the singleton's in it, which is like a very cool thing that is like really kind of hard to do in other languages. So that's a fun little C++ trick. But so term B left, gun component get socket transform muzzle A, otherwise gun component get socket transform name muzzle B. The gun was already, this is kind of like useful. The new assets that we got are double barrel, and it just so happens that the temp asset that I made for my tank was also double barrel, so the code was already set up to differentiate the left and right barrel, so I'm just using that to separate muzzle A and muzzle B. So now it should be shooting. As you can see, it's not turning to face us, and the bullets, although they're coming out of the muzzle, are not in the direction that the muzzle is facing, which sucks a lot, so let's fix that. And this is where it's gonna get, like I said, a little annoying. So in the posable mesh tank, I have this like aim towards target thing, where it's like just driving this swivel joint name, right? Was that it? Yeah, this is if you're in aggro, you're gonna swivel towards the target. So this one was like, it wasn't actually rotating the tank, it was just like animating a bone at the root of the tank. That was like useful because I could like position the tank relative to the spline and then position the bone relative to the tank, and it kept all the code easier. But I think now it's like annoying because I actually just want to rotate the tank. So let's change that code. When you are, so let's see, when you are aggro, which in this parlance means you're in your, so like here's the state machine for the tank, just so you know. There's like idle, which is usually like I'm not doing anything. This is the state you go into. There's patrol, which is like, I have a spline. I'm gonna go back and forth across the spline. So I'm like going forward, I turn around, I go backwards, I turn around. I think I might split this into like patrol forward, patrol backward, and patrol pivot or whatever. But then you have like a range of states that are all your aggro states. So you have antic, this is, it's short for anticipation. This is like, oh, I noticed you. And then you have shooting, which is like boom, 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 boom. I'm shooting on like a timer. And then you have like shooting cooldown, which is, I forget if this is when you exit aggro and there's like a second before you start patrolling again, or if this is just after you shoot, you're like in shooting cooldown for a second. Let's actually look at my state machine and see what that means. So you have your shooting state. Oh, this was all just the posable mesh stuff. Here's the main state machine. Okay, so you have, so when you're in your antic, once you're done, you've gone a certain number of antic seconds, then you enter your shooting state. In your shooting state, you have a timestamp, and every time you like pass your timestamp, oh, that's right, it shoots in combos, right? So it shoots in threes. It goes pew pew pew, and then it waits, and then it goes pew pew pew, and then it waits. So we're like, hey, if you finished a combo, go into cooldown. When you're done cooling down, if you're still aggro, then you should start a new combo, like another 3 volleys. Otherwise, you should enter into this cooldown state. And then it looks like what the cooldown state does is it pivot value 180 plus 180. Oh yeah, so then you're basically just rotating back to align to the spline. And then once you've been in the cooldown for enough seconds, then you return to your patrol state. So let me see here. Yeah, and then when you're shooting, you can see I've got this like the direction is actually, it's like trying to shoot directly at the target, not just in the direction of the barrel. I was like, hey, maybe you should match the barrel or something. So this is the code that I need to modify to change that. But right now we just want turn your body towards the target. So let's write a. This is obnoxious. It's easier for me to like solve problems I already know how to solve. I hate having to read my own bad code and then figure out what I should be doing. So in antic, what it does is it hops. It like jumps up really quickly. And then this anchor transform, this is the spline, right? Oh, but you also have pivot angle. Okay. So anchor transform was a helper that I wrote, which was like, hey, get your spline, get your transform along the spline. If you're facing in the reverse direction, rotate 180 degrees, and then also rotate this pivot angle that you have, right? So every tank, in addition to having your distance along the spline and your direction along the spline, you also have this pivot angle. And the pivot angle is a damp float, which basically just means it has a current value, that's your angle, and has a speed, that's your angular velocity. So what we really want to do when you're aggro is, oh, did we lose the boy? What you doing, buddy? Okay, bye. Oh, this has been the most boring part of the stream, I know. What we want to do is basically just say, let's get rid of this like hop stuff for now. Or actually, let's just write a function, which is like update pivot angle, update aggro pivot angle. So what this is going to do is let's go below our big annoying function here. This is going to, like, given our position and given our aggro position, like the position of the player or the other target that we want to shoot. This is going to compute the local angle relative to our patrol spline that we should be facing. And to make that easier, I'm going to add another helper function here, which is get anchor transform underscore no pivot. Whew. So then here we're going to say my location is, so we're going to say so there's our reference transform. We'll just call that transform. TX is just a common abbreviation for transform. You'll say TF sometimes. You'll see XF or XForm. These are all just, nobody likes typing the word transform. We have my location is TX.get location, naturally. Aggro location is get last aggro position. And actually, what we're going to do so for the aggro location, instead of pointing directly at the target, we're actually going to do some dead reckoning, which means if the target's in motion, we're going to try and point where the target will be rather than where the target is at, right? So you give it your the type of bullets that you're shooting. That's how it knows how fast the bullets travel, how far they travel. You give it your reference location. You give it a little ratio here of how aggressive should your your shot leading be, right? So I'm saying I go halfway between perfect shot leading and no shot leading. So the target direction is the aggro location minus my location. Then we want to get that in local coordinates. So target direction local is tx inverse transform factor target error. And then the local pivot angle, then we're going to say target dir local dot, this is just, we're going to avoid doing math today. Get orient, what is it? To orientation rotator dot yaw. We want the local yaw. This is all very wasteful. I just computed 3 angles and I only grabbed one of them. Shameful. And then we're just gonna say pivot angle dot update degrees near So the target is target angle. The duration, and is that angle a degrees right? Yeah, this is in degrees, so this is fine. Let's just say you have like 0.5 seconds of lag. I don't love this. I don't necessarily want to just like low pass filter your rotation, but like maybe this is good enough for now. And then, so we have this update aggro rotation. And then when we're shooting, and then when we're in cooldown, I think, yeah, shooting cooldown, we'll do that. And then we're in cooldown. Okay, this one just like drives it. So, does this work? It seems like this should work. Because we'll mess up my old tanks for now, but I don't know if I need to do a full rebuild, but let's try. So now it's facing us. Tank treads are doing its nice thing. So it's actually kind of interesting, like it can pivot, so it can face me, but it also has that turret, so its turret can face me. I wonder if like we can do like a 2-layer thing where its main body is like like it's really slow, but then its like top turret is like a lot faster. So let's see. And actually, oh, I forgot to test what happens if I leave aggro, if it goes back to normal correctly or what. Go far enough away. Boy, it really has a long aggro distance, doesn't it? Yeah, it seems to be going back normal. Here, actually, let's mess with those aggro distances. That was pretty wild. What's going on here? Actually make these aggro distances real small. Just for testing. know what I'm noticing? The muzzle flashes aren't underneath the barrels. Let's move those. Whew, okay. So we actually don't need Dead Reckoning here because we'll have the turret. So get last aggro position. And we can actually make it rotate a lot slower. And then let's go up to where it actually shoots for now. Now it should just shoot in the direction its barrel's facing. Which is not particularly smart, but it works. You know, now that we got this guy, since I can make him bigger, I wonder if I should make him a little bigger. Yeah, so it's all very stiff right now. I think what it's missing is the turret should swivel and should be able to aim more accurately even if its body's taken like forever to align. Turret should also be able to look up and down. So like if I'm flying above it, it should be able to point up at me. And then I also think like the recoil when it shoots, there's like no recoil right now. We should have like, not just that the barrels go ka-chung ka-chung, but that like its whole body is like, ooh, like it's leaning backwards, right? Like as you're going. So, much to consider. Let me look at, like we can make it go like boom, boom. Let me turn this off. We can make it go like boom, 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 like every time it shoots. I wonder if that's something we could even just do with the material, like with vertex offsets. That would actually be, because like the thing that's wild about having recoil on the guns is that that's also determining how it shoots. So there's like a feedback loop happening there, whereas like if we just move the vertices, not only would that be cheaper, but it wouldn't affect the location of all the sockets that we're sampling for stuff. I mean, we're already getting some of this, like, they go up and down a little bit due to this, like, idle animation that it has. But much to consider. I also just need to go into that material and take the texture down. I think it's way too textured. Like it kind of doesn't match the rest of our anime aesthetic. So that'll be good. I can also just go, there's like, first time chat. The Running Bird says, thumbs up? Seems good? Thanks. Let's go in here. I bet it can like yank up. Like yanking up the brightness should make it. Yeah, that already gives it more of a cartoony feel. Running Bird says kapow. I agree. I think I left my Unreal volume way too high. Let's take that down. Running Bird says 10 out of 10. Ah, thanks, Bob. Okay, so let's look at it. So the tank, we have the shoulders component. And this is what can drive this swivel here. So let's... What should we do? What should we do? How about we just write a separate state machine just for the yaw on the turret, right? Because we'll have the turret, it can yaw. And I think it has a little bit of like pitching power too, right? Like it can go up and down just a little bit. Yeah. Maybe like 10 degrees at most. But we'll go back to the boring place, back to the code. And we'll have a new function here, which is update turret. And while I'm splitting out functions here, I'm gonna say update treads. I'm gonna move all our tread logic into that, just so our like one function doesn't get way too long. Yeah, so here was that whole tread method. Say if tread mid is null, turn, then we'll just say boop. Here's all this stuff. One of the advantages of moving stuff out into a subroutine is you can convert a lot of these branches just into early outs, which some people don't like that as a like as a programming technique, but I like it because it means I can keep most of my code at one indentation level instead of it just getting deeper and deeper and deeper and deeper. Like I actually like stuff to be as flat as possible. I don't like stuff being deeply nested. I understand that like nested things have structure, but end of the day, I usually just think of this game logic as just being like a list of stuff that goes from top to bottom, and I like to just read the list rather than like mentally having to like go in and out of like branches and scopes and stuff. I mean, you do a lot of it, but once you start indenting like 3 or 4 times, it's a bit ridiculous. But then we'll also have update turret event.update. So for the turret, we are modifying this shoulders component. For now, just as like a quick test, let's just make sure that yaw is the angle that we actually want to control. Sometimes, you know, you saw earlier the bones in this asset pack that I got are rotated weirdly. So like what's logically yaw might technically be some other angle. So let's just test. So all I did in my turret logic right now is just going to keep spinning around. So you go simulate. Yeah. There it is. All their turrets are going around. You can see when the main body pivots, it like can be like constructive or destructive interference. That's kind of fun. Zoop, zoop, zoop. And then let's check the pitch, right? Like if we say like rotation.pitch equals like a sine wave. We said it could go up to like 10 degrees, right? So now they should just be going burp, 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 like up and down on a sine wave. Okay, now we got problems, right? Because it's... Okay, it's pitching up and down, but because all these assets were authored sideways, like looking down the y-axis rather than looking down the x-axis, instead of doing this, it's doing this. Dun, 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 dun. So I think what we really want to do is trying to think about this. we want to rotate not around the normal y-axis, but around the x-axis. So this is just, instead of using Unreal's built-in Euler angles, which assume that all your axes were labeled correctly, because the axes weren't labeled correctly, I have to construct the rotation like explicitly with angle axis rotations. Quat is just like fancy math speak for angle axis rotation. So this is still wrong, right? Here, let's just make sure the yaw is like 0. And let's actually look at this asset. Enemy tank 2. So yeah, it is facing down the y-axis. So we want to rotate about the x-axis, whoops, in order to apply pitch. Yeah, so now it's going up and down, right? Actually, let's make it go up and down faster with more of an amplitude just to really emphasize it. Okay, now they're all head banging. Love it. And now we can have the yaw spinning around. Yeah, so now it's rotating around, but the pitch is still local to wherever the yaw is going. So now we're computing the rotations correctly. We know how to go from a like pitch yaw combination to that. So now let's make a say target rotation if this is just a check if we're in the aggro state. If we're aggro, then we should be pointing towards our aggro target. And if we're not aggro, then we're just going to leave the rotation alone. We're just going to be moving back towards this. So then we're going to say, once again, I'm using a low pass filter. I'm not in love with this, but this is just like the easiest thing to do on short notice. I will come up with a more intentional rotation later. Is there an overload of this which takes a quaternion? Doesn't look like it. That's so annoying. I have to actually convert it into Euler angles. Anyway, so yeah, if you're aggro, we'll do some similar stuff we're doing before, like actually what I'm gonna do here is I'm not gonna let the swivel turn all the way. I think the swivel can mainly only go like let's say up to like a maximum number of degrees, like 90 degrees or 60 degrees or something. So we're gonna say pitch, we're going to limit to -10 to 10, and maybe 12. Oh, actually, I gotta remember, we're actually constructing this rotation backwards way. This can be fixed. Cool. So let's build this. Now, when I get into aggro range, it should like start trying to get me. And we're a little over on time, but let's at least like see how this works. Okay, so it basically works, but it looks like what's happening is they're like overshooting because like two things are rotating at the same time. So I'm wondering like as the base pivots, if the turret should like automatically undo that or something. I don't know. I need to think about this. I think it might just be because I'm like layering a low pass filter on top of a low pass filter. It's not great. Oh, also I think my pitch direction needs to be inverted. It looks like they were aiming up when I was down. So actually, instead of negating that, let's just negate the axis. Yeah, now it's pointed down. When I'm up here, it's like kind of pointing up. Or is it? I don't know. I'm confused. Are they pointed down now? Let me just say the pitch is... In Unreal, pitch is annoyingly backwards because it's left-handed, so you think a positive pitch would be pointing down, but actually a positive pitch is pointed up. So if I have 20 degrees here, they should all be pointing up. Nope, they're pointed down, so this doesn't need to be negated. Yeah, now they're all pointing up. So, Why are these dinguses pointing up right now? They should be aiming down at me. Let's do some debug drawing. Heck? I think it's because they were aiming from their base to me when they want to be aiming. Yeah, there we go. They're getting smarter. I think actually I want my location, instead of using the component, it's going to do a fixed position above their ground position. That way it's more stable. Move down a little bit. Yeah, there we go. And you can see, due to the dead reckoning when I'm moving, they're actually aiming in front of me. That's part of what's contributing to them being actually able to hit me. I'm going to take the pitching amount down because we're actually going to, instead of pitching with the turret, I think I want to pitch with the gun. Boop, 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 boop. So. Ooh. Oh, for differ. Oh, okay. So, but I think that's probably good enough for today's stream, right? We've been on here for 2 hours. Let me just see how they look compared to our other fighters. So here we can test with the tank commander. And then here we can test with the smuggler ship. Which is a little crazy right now. I need to kind of get it under control. Cool. Okay, I think this is a real fun stream. We got the tank treads working, we got the basics of its main body and its turret rotating. I just need to like think of some like better logic for how that movement works other than just doing like a blur filter on a target position. Like I think because it's like more mechanical, you want it to be like instead of just like very smoothly sort of going between the different things. Also, the turret needs to be able to go up and down. And then, yeah, I could probably go through and start replacing stuff in our other scenes. But as always, we do these streams every Friday. We do it from 2 to 4. It's about 2 hours. Recently, we've been working on like a tunnel shooter section, although for this demo that I'm working on right now, kind of like pressed pause on that, but we'll be pressing unpause on that hopefully shortly. And yeah, the game's Nightshift Galaxy. You can follow at Tiny Galactic on Twitter to get like official updates, and there's also like a Discord link there if you want to like join the AMA or just follow the devlog thread. It's our like anime arcade game that we're making. So anyway, this is fun. Hope you guys liked it. Have a good weekend.